Hello everyone and welcome to today's webinar. I'll be your speaker today. We are thrilled to have you all here and eager to share some exciting information about battery materials with you. Before we begin, I would like to take a moment here to introduce myself. My name is Rama Ghosh and I'm a global product manager for material science based out in India. I have pursued my Ph.D. in material science, specializing on synthesis of nanomaterials, nanocomposites for biomedical applications. I am confident that this webinar will provide you with a valuable insight. So let's get started. Today, our discussion will be highlighted as Introduction of Merck, Batteries overview, type of batteries. 2D material, solid state battery, our offerings to accelerate your research and question and answer. Before going to introduction, I would like to give you a small introduction about Merck. We are in business last 350 years, having 350,000 products from chemistry and biology spread in across different applications. Material science is one of them, having more than 45,000 products, especially focused on biomedical, electronics, and energy. In biomedical, we supports for polymerizations tools like wrapped, ATRP, different kind of polymers, monomers, additives, initiators, cross-linkers, and solvents. Similarly, in electronics, we are supporting for two-dimensional materials, organic semiconductors, carbon nanomaterials, alkane, thiol, sealants, and especially deposition materials like solution precursors, CVD, ALD. And in energy, we are having inorganic nanomaterials, for example, silver oxide, and then copper oxide, gold nanoparticle, silver nanoparticle, iron oxide, etc. High purity metals, high purity metal salts, ceramics, different types of oxides and electrolytes. Today, I will be pay a little bit more, attention for energy materials. In energy materials, our product line is highlighted based on the application. For example, as fuel cells, solar energy, hydrogen storage, and of course, lithium-ion batteries. I would like to take a moment here and to give you the batteries overview about the market. Battery today, battery is an integral part of our life. It powers our life wherever, whenever you need it. As you all know, there are two types of batteries, primary and secondary. Primary batteries are very expensive as compared to secondary, also harmful to the environment. I believe you all know that nearly 15 billion of, the primary batteries were thrown across the world every year. And finally, they landed in, ended in a landfills. And these batteries are, containing lot of toxic heavy metals, alkali and acids, and which is the main reason for, harmful environmental impact. On the other hand, rechargeable batteries are inexpensive as compared to, primary, and in long run, they are helping the environment to save as well. Sorry, I'll take some moment here because my system is automatically moving. There are a couple of secondary batteries, as you all know, nickel cadmium, nickel metal hydride, lead acid, and lithium ion. But lithium ion is widely used right now. Nearly 65% more than that is utilizing lithium ion battery. What is the reason behind it? The interesting thing is about the chemistry of lithium metal, and which has the potential to fulfill the current demand of energy. Now, if you see the battery market, according to Bloomberg reports, there are 56 billion electric vehicle passenger cars will be available in the market in 2040 across different countries: US, China, Japan, Europe, India, South Korea, and rest of the world. And the demand is increasing annually by 25%, and which will be landed at 3,600 gigawatt in 2030. And overall, if you see the market, there are 41.1 billion USD market from 2001 to growing 116.6 billion in 2030, and which is CAGR of 12.3%. And the most interesting thing that APEC is going to share the highest market of lithium-ion battery. Why it is so? The growing demand can be fulfilled by lithium-ion batteries because of its different kind of the features: high energy density, maintenance, and the versatile. And it also reflects in the publications. So this kind of, when you need to fulfill the demand, need to necessitate the R&D also for that, to improve the features like for efficiency, cyclability, extension, charging speed, safety, cost reduction. And today, if you see last 10 years, there are nearly 217,000 publications came across different sites on lithium-ion battery. Among them, 123,000 is only the patent registered across the industry and academia, and which actually indicates, the potential of battery technology to fulfill our global demand. Now, when we talk about the batteries, the batteries is always defining by their chemistry, and type of battery is dependent also the cathode, cathode chemistry. So in cathode chemistry, it not only, depends on the battery performances, but also the demand of the material decides. So as per that, there are three classes of oxides, and if you go back little bit, in the year of 1970, the first Professor Whittingham has introduced metal dichalcogenate as an intercalation compound, and later in 1980s, as you all know, Professor Goodenough and his team introduced lithium cobalt oxide as the first cathode materials, and which is predominantly studied and used cathode for consumer electronics. And in 1991, as you all know, for the first time, Sony has commercialized lithium cobalt oxide and carbon cell for consumer electronics. After that, they never look back. Lithium-ion battery potential grows every year in double fold. This lithium cobalt oxide is a layered structure, and it has high electrical and high ionic conductivity with good reversibility because of its ABC type structures. Also has a higher energy density. Operating voltage is also high, nearly 4 volt. Despite this kind of very good electrochemical performances, these batteries, lithium cobalt oxides, is not suitable for EV application. The main reason is the structure instability due to delithiation factor, as you all know. After that, lot of research happened after 1991 also, and one of them is the NMC, which you all know. This is the lithium nickel manganese cobalt oxide cathode. And till now, so far, it is the widely researched cathode material. And the metal, each metal actually, contributes a lot of potential to the NMC. NMC, if you see, provides, low internal resistance from manganese, high capacity for nickel, low cost from the cobalt. And not only that, it also have, a lot of impact for, using, changing the stoichiometry. Now, if you say, from the beginning, it has started NMC 111 composition. Now it is NMC 811, which is widely used for EV applications. At the same time, NCA, which is lithium, nickel, cobalt, aluminum oxide, another type of cathode, similar kind of structure shares like NMC, but it has also leads good capacity of retention compared with NMC 811, and also incorporation of this aluminum by replacing manganese minimize the detrimental phase transition, hence increase the thermal stability and also increase the operation voltage with reducing the overall cost. Now, is this enough for for the application of EV? Because as you will know that battery cost and safety is the main cause to tremendous research for next generation cathode or anode materials. So another type of structure is the spinel. As you know, this is the spinel structure, which is a three-dimensional structure, also introduced by Goodenough team only. And in this structure, if you see, manganese occupy the octahedral, lithium occupy the tetrahedral side, and they share, say, cubic closed pack array. It has a good structural instability, high electrical and its lithium ion conductivity, charge discharge characteristics, even with the good reversibility compared to LCO, that means lithium cobalt oxide. Despite that, this is limited use. The reason is their low lifetime, and at the same time, now in the EV industry, what they are blending NMC with LMO. 70% NMC is blended with LMO so that both the characteristics come out, both the features come out properly, and then can use for their further application. Another class of cathode is polyanion oxides, as you all know, which is right now widely used cathode materials, lithium iron phosphate, LFP. The main reason of its structure, you see, it is a one-dimensional structure, and it has an excellent cycle life. Most importantly, which is the concern factor for the lithium-ion batteries, the safety. This cathode has also increasing the safety property, elevated thermal and electrochemical stability, and this is all happened because of structures, which is PO4 tetrahedral, or if you replace by X with sulfur, molybdenum and tungsten. This is the study also going to happen. So if you compare the layer and spinel along with the polyanion, you can find very distinct differences for the use of electric vehicles application or EV application, especially other than consumers. So polyanion, in terms of polyanion oxides, the poor electronic conductivity is one of the main concerns along with low densities as compared to layer and spinel. But at the same time, LFP has lower cost because of iron. Cost is going to reduce if any company is using cathode as a lithium iron phosphate as a cathode material. But are they able to reach where they want to reach? No. The reason is there other features, especially electrical and conductivity. In that case, lot of studies also happen and is increasing and day by day to increasing their potential to use as a cathode by modifying the chemistry behind it. So like they are using coating chemistry also. They are coated lithium iron phosphate with carbon, as well as they are also doping with the element like metal elements or the non-metal elements, so that they can increase the potential of the features, and they can use, which also enhance the safety, at the same time also reduce the cost of the final battery. So when you are working on the modifications of your cathode, there are a lot of technology has been used so far, and this is the widely used method to make your cathode, like hydrothermal, solvothermal, salt gel, salt state, co-precipitation, emulsifying, spray, pyrolysis. Now the main question is, like, when you want to increase your performances or want to modify the features of a battery and want to do the further cathode chemistry, you require a lot of precursor material. In R&D especially, right, more than use a ready-to-use cathode, all the R&Ds are working on different directions to modify the properties, to modify the features. In that case, Merck has a wide strength in terms of providing the precursor materials to develop your cathode. Like, salt, solution precursor, as I showed in my first slide, all the precursors to make your cathode, it is available in the website as well. Now I am moving to another component. As you know, that anode is an also, inseparable part of a battery technology. So the performance and the nature of the performance of the battery does not only depend, the cathode material, anode materials, but also the morphology of the material is very important when you choosing your anode. Lot of study is already happened, largely on the intrinsic characteristics of the anode material. But as of now, many high performance anode materials has been used also for fabricate your battery. Among them, these three: LTO, lithium titanate anode, tin zinc silicon anode, and carbon anode. When it has been used as an anode, it is also found that there are a lot of challenges, especially graphite. Graphite is widely used anode for a lot of applications, whether it is consumer applications or even in the EV applications. The main factor I just wanted to tell you that when you used carbon as an anode or graphite as an anode, the exfoliation of graphite, because of co-intercalation of the electrolyte solvents happened. At the same time, degradation by manganese also happening with when you use with spinel LMO. So when you use a cathode which is LMO with the graphite, degradation of manganese is possible to happen. And these challenges is really a big challenge to degrade the performance of the battery materials. So when we design or when we work for a next generation anode, it is very important to keep some of the characteristics to remind that how you going to choose the anode materials, how we need to choose what kind of anode materials will give us the best benefit to use as an anode in the battery application. First is the compound should be crystalline, or it should have an empty sites in the host crystal lattice, in the form of as an isolated vacancies or as one-dimensional channel, two-dimensional layers, or channel in the 3D network. Second most important thing that the host compound should contain one transition metal or the rare earth metal which has one or more stable vacancy states. As you see that vacancy states is important when you make your anode, choose your anode materials. And the third is any material which you are going to choose an anode should have the potential property, electronics property especially, that have semiconducting or insulating behavior. Till now, there are a lot of studies happened as per the report. As I said, 217,000 publication came across on lithium-ion batteries, which in last 10 years only. It means every year nearly 21,000. So you can say that how much research is happening in that, especially in cathode and anode. So promising anode materials, when you select for higher energy density, these are the type two-dimensional material layer structure, which will be our next generation anode. Another is the elements of the metals which have the stability or the capability to form alloys with lithium metal, especially silicon, which has been used, tin, antimony, bismuth, zinc kind of metal ion. And the third is oxides, fluorides, or sulfide. That means the ceramics has the property, or their composites, which are basically in the nano and macro form. You will be shocked to know that, lot of nano material has been given a better performance than a bulk, for cathode or anode technology. And so far, lot of study happened also. So when you are choosing to make your own anode, keeping the conditions in mind, Merck is a platform where you will get on kind of precursor material to make your anode as well. For example, you are looking for the metal, we are having that. If you are looking for carbon materials, in terms of CNT or single wall, multi wall, surface functionalization, graphene, reduced graphene oxide, even lot of ceramics like nitride, carbide, titanides are there. I'm just giving a little idea about you that when you go to the website and search for the product, it should be easier for you to get the information. Now, as I said, if you see in this, criteria, there is one thing I have mentioned is the two-dimensional structures. Why these two-dimensional structures are chosen to be the next generation materials as well for the cathode, anode, or even they are using as a collector also. If you see, this is the general characteristic, not only the physiochemical but also the electronic and conducting property of these two-dimensional materials. For example, graphene and transition metal oxides, transition metal dichalcogenates, magazines, and genes precursors are having the high potential to make and to use as a cathode anode. This is the reasons, their high surface interactions, weight, they are very lightweight, remarkable electron conductivity. At the same time, they have higher thermal stability, thermal conductivity. Mechanical strength is very important when you're making an anode or cathode to choose. It should be flexible, especially when you work for wearable devices. You are wearing a device for 17 to 18 hours, so it is important to have the property in the material as well. As I say, material design is always important for your final fabrication. So it has been also proved that these 2D materials also protect the electrode from pulverization, overheating, then battery flexibility, rate of performance will high, catalytic activity they will provide higher, so even they provide the higher stability as well. So that is the one reason these 2D materials has been used widely for all kind of components for the battery applications right now. Now I would like to give you a little bit idea like what is 2D materials. If I say, as you all know, it's a lower dimensional material, and it is generally isolated from the bulk crystals only, and along with the compiling physicochemical structures, it has electronic properties. So if you see here graphene, black phosphorus, transitional metal dichalcogenates, magazines, hexane boron nitride, graphene from metallic to semiconductor, then insulating. So every type of 2D dimensional material has their own electronic properties. Especially one criteria which I mentioned is, the semiconducting and insulating nature is very important for an anode. So these are the two-dimensional materials which have wide range of electronic properties and tunable, band gap, which are always helping to use as an anode or cathode, especially anode applications. We have, as a Merck, we have an exclusive source for two-dimensional materials. I just want to give how these are. If you want to ready-to-use material, we have in the form of powder, dispersions, inks, which will reduce your processing time. At the same time, this product has chemical functionalization also. Suppose you are looking for surface functionalized with any of the carboxylic group or any other, amine group for tune your electronic properties, we are also having that. These are very high quality as well as structure specific materials. So it is completely depend what kind of applications you want to do in terms of, it is for the wearable electronics or it is for any kind of consumer electronics, or you are, trying to fabricate for the EV application. So all kind of informations are also available in the website, which will definitely give you a lot of insights to design your cathode and anode materials. Now, when you talk about LIB, we are always two things come into our mind. Mostly the concern about the safety. We are worried about the safety all the time. Lot of incident happened in lithium-ion battery, catching fires many times, and those catastrophic failures is happening because of shortening, the overcharging, separator failure, sometimes the electrolyte breakdown and pressure buildup, abusive situations also happen if the temperature is very high. So safety always a primary concern. To overcome this safety, last 5 years especially, lot of research happened on solid state electrolytes, or you can say solid state batteries. What is the difference? As you know, for solid state battery, it's a very minimal layman language. It is the electrolyte difference only. In liquid lithium ion battery, the electrolyte is your liquid form, and in solid state battery, you are using a solid electrolyte. Now, when we are talking about the solid state battery, what kind of benefits we are looking from other than the safety? Most importantly, as I said, these solid state batteries are very stable in thermal condition, more than 500 degrees centigrade, as per 120 to 500 degrees centigrade. That's how thermal stability is. They are simply architectures, and most importantly, easy to assemble them, and higher electron energy density as well. But at the same time, you can see that lot of challenges are facing when scientists are working on solid state batteries or solid electrolytes. One of the worst things happen for solid state, that is the low conductivity, or you can say poor ionic conductivity. It's a solid closed pack structures. So ionic conductivity always is a challenge. Their interface with electrodes, slow charge rates, because of the conductivity low, the charging rate also goes reduced. This is a simple information I would like to share with you. Last 5 years, in more than that, solid state battery technology was developed. Japan is the leading country for their technology, and they, especially in Japan, lot of research is going on solid state battery. Now, not only Japan, across the world, the solid state battery is coming up. The main reason is that lot of automobile industry, like for Mercedes-Benz, then Tesla. Tesla is already using as well. Then Volkswagen. Lot of EV industries have already invested a lot of billion of money for solid state batteries. And these are the companies which are already highlighted and patented more than 1,000 each, like Toyota, Bosch, Panasonic on solid state batteries. You can say the potential market for solid state battery as well. So when you talk about solid state battery, there are only 3 types of batteries coming into the types of electrolyte is coming into mind. One is the polymer electrolyte, one is oxide and sulfide. Polymer is a promising candidate, yet proved because of its ionic conductivity, because of its safety especially, and the stability. So here I have tried to show you the differences of this electrolyte. So when you talk about the conductivity, sulfide is highest ionic conductivity comparable to oxide and polymer. Polymer, the most challenging phase for the polymer electrolyte is their ionic conductivity, and that is one of the reason initially only polymer electrolyte was there, but now solvent-free electrolyte, then gel electrolyte, polymer composite electrolytes are coming into the picture to increase the conductivity. Similarly, when you talk about thermal stability, as I said, solid-state batteries are popular because of its higher thermal stability. So when you talk about polymer is stable up to 120, whereas oxides is more than 500 degrees centigrade and sulfides are 450. Similarly, for manufacturing, or you can say how processability, how easy or fast the processability is. Polymer is easy to flexible to process, but for oxide it's very rigid. Chemicals are also very complex. If you see, most of the oxides polymer was synthesized by using the chemical vapor deposition or atomic layer deposition techniques, and which is very critical techniques to develop the oxides. Similarly, sulfide is quite easy, but compressible at room temperature. And when you work on the moist battery, always keeping in mind that the moisture is very important for battery technology. So electrolyte uses, they are, when polymer we are using uses water reactive, but when you are using sulfide, they are very prone to, exposed to moisture to form hydrogen sulfide. So this has the limited reactivity also into the cells. And this is the, features. This is a radar diagram. You can see liquid electrolyte, quasi-solid electrolyte, which is solid and liquid combinations are using, and this is solid electrolyte. And these structures can give you a little bit more idea why this improvement has happened, why this technology come into the picture. So in solid electrolyte, from this radar diagram, you can see safety is the main point. Safety, your safety will increase. Similarly, you will get a wide stability window and thermal stability. These are the key features or the achieving feature yet to reach the solid state batteries. But when you talk about the liquid state, the main problem is coming here for the safety. Safety is not at all there, and that is one of the reasons chemistry is changing day by day. Today's generation we are using liquid, but I'm pretty sure there are a lot of research happened that 2025 onwards we will be more focusing on solid state battery in commercialized. Now I would also like to give you little idea what kind of research we are doing for battery technology other than these precursor materials. So in the collaboration with UW Milwaukee with Professor Diwanku, we also introduces 3 different kind of composites with graphene and polymer, which are providing you the first charging experience. So these are reduced graphene oxide enhanced PQS composite. Then this is PMDA composite, and this is NDCDA composite. Now, why we have used this graphene? We have used this graphene in a uniform coating of polymer on graphene surface, which has giving you the higher surface ratio. As I mentioned, the 2-dimensional structures, one of the best benefit is their high surface area. Their high surface to volume ratio is very high, and that is one reasons 2D material is come into the picture to also increase that factor. So it is also increase the charge rate 3 to 6 minutes. This composite does not contain any heavy metal. So in the point of environmental safety, we are prone to protect the environment without using any toxic metals. Secondly, this have the tunable voltage, as well as when you synthesize, we got a very good yield as well. This having the excellent yield for the final product. These products are already available in the website. You can see these are the tests and all information is also there in the website. I will insist insist all of you, please visit the website and look into the product. Lot of literature also we have mentioned there, so that you get a clear idea. Also, if you want to read about this is the article, energy storage material. This is already published, so you will get a lot of information even there also. Now, we are not stopping in the composite formation for, fast charging. Now, as I said, wearable electronics is one of the type of consumer electronics, which is very important for us to, work on. And that is one of the reasons we are also working our next generation flexible batteries for wearable electronics. So when you talk about wearable electronics, whether your, watch, your wristband, or, your pad, safety pad, a couple of things are important for us to focus. One is the mechanical flexibility and stretchability. Another is high energy and power density, cycle life, and operational safety, of course, which is the main factor for that in wearable electronics. Now in wearable electronics also, our related focus area, especially battery cathode. We are trying to use graphene enhanced composite, and which will help us to increase the conductivity, high change rate, improve cycle life. How we make it here, I will show that actually this work is also in the collaboration with Professor Mark Groom from Northwestern University. This is the product number you can see in the website as well, and this is the publications already did it. So here we use ethyl cellulose concentrated few layer graphene ink with active lithium manganese oxide in nanoform, and we had made the composite by using the processability method, and that I'm not going. It is there in the page, and then this product, these are the structure. These are increasing because we use the graphene. Graphene is used as a here, acting as a additive to increase the kinetics also, and that is why this product, give us a very good results in terms of energy density. Stability also is good, and the charge life. When you cycle life is also very high when you charge or discharge the battery, when the battery is charging or discharging. Another thing we also work on, which is our separator for the wearable electronics. Here what we used hexagonal boron nitride. And as I said, hexagonal boron nitride also as a semiconductor insulating material. At the same time, it also helps. It's a two-dimensional material. It has a higher surface area, so we have made a composite using PVDF as a binder and with ethyl cellulose. And this separator has very good surface area, as well as it also porous, also increase increase the performance of the battery. And this work also in the collaboration with Professor Mark Hersham's group from Northwestern University. This is also published in Advanced Functional Materials. I would like to suggest all of you, if you have some time, go and read the article as well. Here, hydrogen boron nitride we have used for two reasons. Not only the surface area, but also for the mechanical properties. As you all know, it increases the mechanical integrity, as well as, because of the low dimensional, it gives the structural and thermal stability of the electrolyte. Of the separator. Second, we also worked for ionic gel electrolytes. In the first case, what we did, we have synthesized an ionogel electrolyte by using ionic liquid and a solid matrix. It is a solution processable technique. It has ionic conductivity, but we found that this electrolyte is poor in mechanical conductivity. So in that case, what we did, we have incorporated exfoliated hydrogen boron nitride as a solid matrix into the ionic liquid gel. As you know, that as I mentioned that HBN gives the mechanical integrity. At the same time, it has the due to its low dimensional and insulating structures, it gives you the thermal stability as well as structural chemical stability also. So it finally we proved that this electrolyte is having a good performance as compared to cell guard. We conducted a reaction experiment with a standard cell guard and also this SBN ionogel electrolyte, and we found that it is not only operated at high operating voltage but also stand good in comparison to cell guard. Here you can see the cells, maybe the cycle rate is little lower because when we first time synthesize or make the size is little bit higher, which is nearly 100 micron. It's a thicker. We also later on work to make it thinner and got it good performance as we expected. Now, since you see that we are not only working for the productions of the lot of electrolytes or the composite, but also we offering to accelerate your research. Now here I would like to show some of our offers, how we are supporting to the scientific fraternity to accelerate your battery applications. Here is that. So first of all, our product has certain benefits in such a way. We are providing you multiple SKUs. Since you are working in R&D, every time you are utilizing or using very different metal products to modify the property or the features. Second is quality trusted product. We are a global brand. As I mentioned, we have a present nearly 175 plus countries. At the same time, these products are well trusted, performance and results driven. We are also supporting extensively for the documentation, especially COA, COC kind of things, if you are looking for. And we have a round of technical people who are helping to, design your protocol sometimes. you are looking, you are looking for some products and you are little bit, probably need support for the technical inquiries. We have a back-end technical team which are also helping to, support you to sometime identify the final product. So as I told you that we are not only, for the R&D, also helping for the pilot scale manufacturing. So our products are in the design to, if you are working on battery development, like you are making cathodes, anodes, or the electrolyte, we can provide you all kind of precursors from high purity metal salts, ceramics, oxide, two-dimensional materials, nanomaterials, chalcogenate solvents, but if you are working device prototyping or you looking for some control experiments and need some, cathode like LCOO, lithium cobalt oxide, LMO, or you are looking for NMC, NCA kind of materials, or to making your composites, carbon nanomaterial, or specialty polymers as an electrolyte, or for example you need ready to use electrolyte like lithium iron phosphate 1 molar in EC, DC, DMC with additives. And we are also supporting a lot of additives to making your device prototyping and battery development. And for battery manufacturing, or you can say for pilot scale, here also we are supporting in some cases, bulk also, especially high purity salts, oxides, ceramics, alloys, solvents, electrolytes. And to analyze your battery, sometimes QC and recycling is there. So a lot of analytical grade products are there. So this is also available. ICP, AAS mass or Carl Fisher reagents are also available. So there is just to a single click away from you. Just go into the website, explore the website. It is nicely built. Lot of information. See, it's not a promotion of the product, but yes, lot of related informations, technical information, guide, selection guide, lot of research articles are available, which will definitely give you a lot of insights to improve the performance of the battery applications so far. Now, I would take, this is kind of websites, that, as I said, our energy materials are designed in such a way. Suppose you are developing the battery, so we have high purity salts. If you simply click here, you will go to the website. Solution vapor deposition precursors, as you know, there are a lot of techniques, hydrothermal, sol gels, solvothermal. For that, high purity metals, alloys in different forms, whether it is a powder, ware, sheet, honeycomb, every forms are available which can fit for your research. Oxides is not only the, in the bulk form, we have also nanoform oxide like 10 nanometer, for example, 50 nanometer of alumina. Then ceramics is carbide, nitride, phosphides are also available. Different kind of carbon nanomaterials, chalcogenates, two-dimension materials. We also introduce, and there are a lot of pipeline products for magazines are coming as well. So metal chalcogenates, there are a lot of wide variety of metal chalcogenates. Hexagonal boron nitride is already there. Then graphene and their components are also available. A lot of quantum dots, polyethylene. As you all know, PO, polyethylene oxide, is widely used polymer electrolyte so far. So we have different versions of PEO, whether higher molecular weight, functionalized. Other than PEO, we have PAC, which is less than 10,000 molecular weight. Polymerization tool. So when somebody is working on polymer electrolyte, definitely this is an important tool, because in polymerizations, lot of people synthesize the polymer from those monomers. So we are here to support to build your own polymer. For that, monomers, cross linkers, additives, and the tools, controlled radical reaction tools are also available. Here, this is suppose you're working on the device prototyping. Now, in device prototyping, I mentioned here electrode sheet, which would be your cathode or anode, a cathode sheet, cathode materials, anode material, ready to mix. Electrolytes is also there. PVC, we have limited separator, only PVC separator, polyethylene separators are there. Okay. So, this is the micro reviews which are, for material matters, we launched it quarterly every year, focused on different kind of applications, whether it is biological or the battery applications, where, in this article, you will get lot of macro reviews from leading researchers across the globe who are writing their articles, as well as, most important thing is the recommendation of the product is also there. Suppose there are a couple of writings on batteries, especially solid state batteries also there. So what kind of materials would be helpful for your next generation battery, they have also recommended. So if you want to, go to the website and just to add your email ID and subscribe it and get the opportunity to read it as well. It is free of cost. So yes, here I'm closing. Now I would like to go to, I'm hand over to Cindy right now for the question and answers. Thank you so much, everyone.